We created a simple Ubuntu virtual machine, and today we'll create partitions and the file system for LFS. We start with Chapter 2, Section 2.2.2. In the software section, we have a list of software or programs that we need installed in the host system. Like we have the list of the software that we need, and we have a script for every package to check if it exists and if the version is valid. To find the script, we can just scroll down, and it's just so easy. Just do a copy paste and run in the terminal. It checks for the packages and if they exist and if their versions are valid. I copy the script into a standalone file directly from the book. There it is. So now let's try to run it. We just do bash and then the script. And the script shows us here the missing packages. As you can see, I'm missing Python, G++, M4, and so on. So let's install them now, just via apt or any package manager you have. After the installation, let's run our script. Everything is good except for this error. It states SSH is not bash. So let's check now. First, let's view the link and see what it points to. As you can see, it points to dash, not bash. So let's correct it now. Also, we have a hint for it in the book itself. It tells you that bin sh should be a symbolic link to bash. First, let's remove bin sh, and we need to use sudo for that. Next, let's create the symbolic link. We use the command ln-s for symbolic and then bash and then what it points to. And of course, you need to use sudo for that. Okay, now let's check the link one more time. There you go. Now let's run the script again. There it is. So now the script is fine and we are ready to proceed. Now that our script no longer produces errors, we can go to the next part. Section 2.3 gives you a heads up of the next chapters. Feel free to read that. Let's move on to creating a new partition. Like most operating systems, LFS would be installed on its own dedicated partition. A partition, you can imagine it like a logical segment of the storage. Windows has C, D, E, all of these letters. Linux doesn't. Instead, it segments the hard drive into partitions. That's how it understands the storage. We can actually view this. So if you search for disks, it should be available on most systems. It's a native utility to show you like a visual representation of the disk space. On my side on the VM, you can see that the hard disk is 64 gigabytes. The first partition here is only 1 megabyte. It sits on div SDA1 and its type is BIOS boot. The second partition is 64 gigabytes. 52 of them are free. It sits on div SDA2 and the partition type is Linux file system. Let's go back to the terminal a little bit and let's do ls-blk, which lists the block devices. We can see here that we have SDA, which is for our disk. It's 60 gigabytes. It's partitioned into two partitions, SDA1 and SDA2. SDA2 is mounted on the root for the file system. Now let's check the disk space. So if you would just do the f-h, it would also confirm some like our findings. Only 11 gigabytes are used from SDA2. and we have 46 gigabytes. So what if we utilize this free space to create a new partition for LFS? This is what I'm gonna do. Now, since we are already on Ubuntu, we are using it, we have booted our system from the hard disk. We cannot, like, it doesn't make sense to edit SDA2, right? So for that, we are going to mount a device like an ISO image, for example, or a disk, so we could modify SDA2. Now, to do that, the book suggests cfdisk and fdisk. I only worked with fdisk, so it's what I'm gonna use. But if you prefer a graphical user interface tool, you can use gparted. Gparted has a graphical interface and it's very user friendly. In this example, you can see like the partition and what storage space is used, and you can manipulate it, everything. In our case, as I said, I'm gonna use fdisk. So let's zoom out a little bit and back to VirtualBox. Next, if we go to devices, optical devices, we can view any attached disks or ISO images. In our case, we just need the Ubuntu ISO image. So you can, of course, check it from here. I already used it before, so it's already available. But in case it wasn't for you, you can click on Choose Create a Disk Image. From here, like, you can add devices, so you add one. And it goes to your storage on the host system, and you can select whatever ISO image you want. In my case, I'm just going to use the same ISO image I used to create the virtual machine. This one. Open. And then we click Choose. So now it's selected. Let's now try to restart the machine. Let's see what's going to happen. Yeah, it booted via the ISO image. You can imagine it like connecting a USB with an ISO burned into like a PC or a laptop. Anyways, let's click try install, and I will stop the record and get back when it's open. And we are back. We are now presented with the welcome message. We don't need to reinstall Ubuntu, so just gonna close it. Let's go to the terminal a little bit. To list our devices, we can use the command +blk. And we can see here we have the SDA disk and two partitions, SDA1, SDA2, which means we do have visibility over the partitions on the main system, and we can manipulate them from here. Now, first phase is to shrink the file system. Now, the file system, like you could imagine that it's still sitting on 60 gigabytes, right? We want to shrink it. Let's shrink it to 20 gigabytes. That should be enough. First step is to unmount dev SDA, but it shouldn't really be necessary, I think, because it should already be unmounted, but let's try. It's already not mounted, which is good. The next step is to check the integrity of the file system for SDA2. Okay, now we can resize. So sudo resize to fs -f dev SDA2, and let's give it 20 gigs. This way we would have 40 gigs remaining, which I think should be more than enough. It's gonna take a while, so I'm gonna stop the record and get back. Resizing the file system is done. Now we need to shrink the partition itself and create a new one. Let's now use the fsdisk command. If you click M, you can see the options. We start with an easy one. Let's print the partition table with P. This is the current partition table. Now, for partitions, we cannot technically resize SDA2, like shrink it, but instead we can delete it and recreate it again. So we D and number 2 for SDA2. And we have deleted the partition. So now if we enter P, we only have 1. But still, we have 60 gigabytes, right? So let's create a new one. Number 2, we enter N. N is to create a new partition, and the partition number it starts from the next. So SDA1, next is 2, and so on. We can keep it as is, so just press enter, default 2. The first sector would be the one right next to the end of the first partition. So it would be 4096. We can just click enter to take the default value. The last sector, now for the last sector, remember we only want it to be 20 gigabytes. We don't have to calculate the sector for 20 gigabytes. Instead, what we can do is give me 20 gigs. That's what we're gonna do. Plus and minus depends on how much you want to take, and the unit, gigs, kilobytes, megabytes, whatever. And we click enter. Now we created the new partition and the size is 20 gigabytes. But then it gives us a warning, tells us that partition 2 contains an ext4 signature. This is because it already had a file system. So it asks us, do you want to delete it? Of course not. We don't want to corrupt the system, right? Or Ubuntu. So we're just gonna say no. Okay, now let's print it one more time before we save. Now we have the partition SDA2 as 20 gigs. So we still have 40 gigabytes to spare, so let's create a new one. We just click N for new. The partition number is 3. The first sector is this one plus 1. And for the last sector, I'm just gonna tell it to take everything. And let's see if it works. There you go. So now our new partition SDA3 is 40 gigs. And these are the start, end, and whatever. So now we can just save. And to do that, we just click W. If you don't want to save anything, and if you don't like it, you can just quit out of it. Okay, so now let's list them one more time. There you go. So the changes have persisted. So we finished phase 1, which is to shrink the system, the file system, and then repartitioning. Repartitioning, we deleted SDA2, recreated it, and didn't remove the signature. This is very important. And for LFS, we reserved 40 gigabytes in the new partition and saved. Now we have a new partition, but it's still not formatted. And for file systems have different formats, ext2, 3, 4. There are many others. For LFS, we are going to use the recommended, which is ext4. So we're going to just use the same command, sudo make file system ext4, and then the partition we want to modify. So let's see if this works. Yeah, there you go. ext4. This is what we want. I think these are, like, we should see them from the Ubuntu system itself. Okay, so now SDA3 should be available for us. Hopefully we did not break anything. I'm gonna now remove the Ubuntu ISO image. And then we're gonna reset. Let's see if it's gonna boot successfully into Ubuntu or not. Okay, we successfully booted into Ubuntu, which means that we successfully partitioned the system and we did not break anything. Let's log in. There it is, our new partition. This page is just has more information about recommendations and so on. I don't want to make a swap partition, that's just my preference. It tells you here that it's optional. It also tells you that there are other partitions that you can create. You can create a dedicated partition for the root, for the swap, for the other ones like home user. I don't want to do this. I'm just gonna keep it as it is under root. Next, it tells us to export LFS, the variable. So just gonna paste it. And this variable will be used later in scripts and so on instead of keep typing MNT LFS all the time. So make sure it persists. Okay, after we created the partition, we formatted it, we now need to mount it. Mounting means to give like an entry for this partition. Let's see if anything changes. Now remember, this was the output before. If I do it one more time, there it is. It's now mounted here. Now, in case you went with the plan of using multiple partitions for each directory, for the home, for the user, or whatever, you're gonna need to recreate them this way. I'm not gonna do it since we only have the root. To make sure SDA3 persists and the mounting point, after a reload, we're gonna add an entry for it in the FS tab. The command already exists, it's in the big warning box. This concludes our video. Thank you so much for your time and have a lovely day.